Transforming complex data structures with arrays. Working with collections, we have the ability to use the map operator to apply a transformation to each element in a collection. A collection can be JSON or Java arrays or XML repeated items. So for example, the collection could be specified as payload, and then we can use map, which is the transformation function, to apply to each element. The map operator will return an array of elements and can be applied to each element in an array or each value inside of an object. Here's an example of some map usage. Inside of the transformation function, we can use $$ for shorthand representing the index or key, and $sign to represent the value of that key that it's currently iterating on. So on the left here, we can see input where we've got an array of two users, first name and last name, Max and Molly. The top transformation shows running payload through map, in which we can specify NUM, $, which would be the index in this case, 0 and 1. And then we can access the value for fname and lname for each element by representing it with $, the key we want to access. In the bottom, you can see us doing something quite similar, but instead of just putting in this structure, we're wrapping it all inside of the key users. So we specify users, and the value for users is effectively going to be this array of users. And to create this array, we once again use the map operator, in which we can then access first name and last name using the $ syntax. Using the index as a key in a transformation. To set the index as a new key, we can surround it with parentheses or single quotes. An example of this is the same structure on the left, and inside of the top row transformation, you can see wrapping those $ in parentheses, which is effectively going to output the key instead of just the index. Same with the second row down. And then at the very bottom here, you can see us putting NUM $, which is effectively going to provide us with the index inside of those single quotes. So again, NUM $, being num0 and num1, and then of course the value coming out of that, which would be the object for each user. Let's see if we can put some of these transformations together ourselves. In walkthrough 10.3, we'll talk more about transforming complex data structures. We'll create a new flow that receives post requests of a JSON array of objects. We'll transform a JSON array of objects to Java. Let's get started. We'll now return to the implementation XML, and inside of the Mule design view, let's drag another HTTP connector inside of the canvas, once again at the very bottom of the application. Let's rename this flow and call it post multiple flights flow. And we will select our HTTP listener. The path in this case will be multiple flights, and the allowed methods will be post. Inside of this flow, we'll configure it quite similarly. We're going to put a transform message in the middle, and then at the very end, we will drop a logger in for the sake of debugging. Now let's double click on transform message, and let's start ourselves off by setting the transformation to payload. Let's open up the preview button and switch it to this 2-pane view with preview on. And let's create the required sample data to execute the preview. Inside of our sample data types requirement dialog box, we'll set the metadata to JSON. And then from the actions box, let's click the ellipse button. Inside of here, let's do the flights underscore JSON example. This should be one we've used in our previous examples, and we'll hit select. In the sample data types, we'll then hit OK. And now we can see the multiple flight array being transformed into the Java object in the right based on our simple payload transform. Let's start off by seeing if we can capture one object. We'll do payload 0 in brackets, and we can see it grabs index 0 of those objects. And if we do .price inside of here, we should see it selects just this particular price, or $1.99. Now, if we wanted to change this up a little bit and print out all the prices collectively, we can put an asterisk inside of here. And you can see here that it knows it wants to create an array list with the price, but of course we're still specifying 0 inside of here. Now, if we make the modification of taking the index specifier off, we're going to create an array list where it only collects the values of the prices. Now, let's see if we can change this up a little bit more. Inside of here, we'll do payload.price. We'll wrap this in array brackets. And we will also, at the very end here, after a comma, put in payload.emptySeats. So now we've generated this array in which inside of the array, we've got a list of prices and then in a list of empty seats. Now, what if we were to use that map operator to return object collections with different data structures? Let's get started with a very simple example. Inside of here, we'll start off by specifying payload map $. And this will create a general structure, pretty similar to what we were looking at earlier. We've got index 0 and index 1 for each object, and it simply prints out all the keys and all the values inside of here. Now, if we took this a step further and opened up payload map, we can then put in flight : and do $. Now, this once again, since map is iterating over each object we have, it is still going to print out 2 objects in the array, but in this case, each object is simply going to have an index of flight, and then the value, which is the index of the actual flight from over here. So what I meant to say is flight will be the key in the output, and then the $$ will effectively be the index of each object respectively. Now after that, if we wanted to do a comma rather, and then type in destination as a key, and for destination, we could do $. It'll look up all the values because remember, $sign is the value, and we can say to airport. And now we're printing out the flight index and the to airport for where that flight is going to land. Another change that we can make inside of here is inside of the destination area, we could replace this with parentheses and $, in which case you'll see we have the 0 and the 1 being printed out. Now, if we change this from airport code to just a single $, you'll see how it is actually smart enough to once again know that this is going to be every key and every value and print all of those out. And effectively, at a higher level here, we still have our flight and the index for that flight being printed out as its own element. Now, let's change the data weave expression just a little bit. In this case, we're going to keep our flight in the index here, but at the very beginning, let's try that expression where we have flight and then $, a value. Now you can see inside of here, we've got a pretty similar structure, but this time it's printing the index with the actual flight itself. Because if we were to take these single quotes away for a moment inside of here, you'd see how it wouldn't be able to resolve. It needs to be wrapped in those single quotes to know that it should use the index and append that to the actual word flight. Now let's see if we can change this up quite drastically. Let's go from application Java to application XML. Once again, this throws errors for us, as we might expect, because we need to specify that root element. So let's go to the left of payload and let's try typing in flights as that root element. And with flights in place here, we've gotten ourselves a little bit closer, but we're still going to have an issue. Now, if we click on this issue here, we'll see a message that says cannot coerce array to object. Now, this is something we're going to look at around how to set up XML with repeat elements in the next section. So let's pause here and hop back to the slides.